All right, day 2 of lesson 1.3, exponents and order of operations. We are on page 17. So order of operations. When multiple math operations are intended to be performed within the same problem, the order in which they are performed will affect the outcome. Take this example where it's the same initial problem, but the work is done 2 different ways. On the left, the work is done simply left to right. So the first thing they did was 23 minus 3 to get 20. Then they multiplied by 6, added 4, and divided by 2. On the other side, they did the multiplication first, 3 times 6 to get 18. Then they did the division, 4 divided by 2 to get 2. Then they did the subtraction, 23 minus 18 to get 5. 5 plus 2 is 7. One is correct, the other is simply being worked from left to right. So clearly, because there are 2 different answers, the order you do the operations in does matter. And the second way is the correct one. Order of operations, a simple way to remember that order is using the acronym PEMDAS, which could be thought as the saying, please excuse my dear Aunt Sally, which means we do parentheses first, then exponents, then multiplication and division from left to right. And addition and subtraction, again, from left to right. So here we have an example. 7 plus 18 divided by 3 times 2. There are no parentheses. There are no exponents. So our first step is going to be to complete the multiplication and division working from left to right. And again, a good note here, that does not mean we multiply first and then divide, but we go from left to right doing these operations as we encounter them. So we do the 18 divided by 3 first to get 6. Then we take 6 times 2. And 6 times 2 is 12. Last addition and subtraction, 7 plus 12 is 19 for our final answer. Here's another example. Here we do have parentheses, so we need to take 7 minus 3 first. That is 4. We have an exponent, so we square the 4. 4 times 4 is 16. Then we have multiplication. 8 times 5 is 40. And lastly, addition or subtraction. 16 plus 40 is 56. A more unconventional way of seeing problems with order of operations might be like this. So here we have what looks like a problem in a fraction. And these are used with regularity in welder applications. We say the parentheses are implied, they're never actually written. The division bar means both division and that the above and below operations are in parentheses. So this large fraction here, 17 plus 5 times 2 over 15 minus 4 times 3 is the same as the whole numerator in parentheses, or as you see here, brackets, and the denominator also in brackets. So we have to follow our order of operations. So the first thing we do the multiplication that's in the parentheses. And again, we're assuming, or we're implying, that these two are both in parentheses. Then we do the addition and subtraction. And the last thing we do is 27 divided by 3. And we get 9 for our answer. So at this point, go ahead and pause the video and take a look at the examples shown here. And once you calculate them and find your answer, go ahead and start the video back up and check your work. Our first example, there are no parentheses. So we do, and there are no exponents. So we do multiplication and division first. 7 times 14 is 98. And now we do addition and subtraction going from left to right. So 31 plus 98, which is 129, minus 3 to give us 126. If we throw some parentheses in there, now we have a little bit different order. We first do the subtraction that's in parentheses. 14 minus 3 is 11. Now we do the multiplication. 7 times 11 is 77. And lastly, we do the addition. Same numbers, same operations, but one has parentheses and one doesn't, and we get a different answer because of that. The first fractional example, we have some multiplication in the top of the fraction. 21 times 5. And all we have are addition and subtraction in the bottom. So let's go ahead and now take care of addition and subtraction. 40 minus 105 is 35. 122 minus 119 is 3, plus 4 is 7. Show that in 2 steps. And 35 divided by 7. The last example, there are actually 2 ways you can do that one. I will show you both. The first method, go ahead and multiply 56 times 9. 504 divided by multiply 45 times 8, 360, and then reduce. Well, let's see. 4 divides evenly into both. So we would get 90 in the denominator, and in the numerator, 126. So there's a two that still works. If I divide by 2, I would get 63 and 45. Now I can divide each of those by 9, and I get 7/5 as my answer. Whew. That's the answer I get when I do the multiplication first and the simplifying second. I could also simplify first and then multiply second. So 56 times 9, 45 times 8. And the way that I can simplify first is if there is a number that evenly divides into one of the numbers in our numerator and one of the numbers in the denominator. For instance, 56 is 8 times 7. So I have an 8 in the denominator. 8 divided by 8 is 1. 56 divided by 8 is 7. 9 divides evenly into both 45 and 9. 45 divided by 9 is 5. 9 divided by 9 is 1. Now, if I multiply straight across, I go right to my reduced answer. So there are some tricks. If all you have multiplication, you can use this reducing trick to get your answer. Unfortunately, that's the only trick for this. At the bottom of page 18, you'll see this funny picture. That's just a great picture. There's no problem to go with it. So you have some homework, doing some order of operation problems, and I will be back on Wednesday for our skill drill and to answer any questions you might have.